of book authors. So he brings a unique background in engineering with an interest in network sciences, and his research focuses combining those two things to study the sciences themselves, which I think is an interesting combination. And today we'll hear a bit about that network structure as it relates to gender inequality in the sciences. So let's welcome Junming.
Thank you, everyone. Can you hear me? Okay. So it's glad to be here to present our recent work on science of science. So we try to quantify the gender inequality in academia and explore the reason behind it. So this is a working paper with Alex Gates, Roberto Senator, and Lazo Barbaci at Northeastern University. So why are we working on science of science? Maybe some of you might know that we are a group of complex networks. And we try to understand complex phenomena and find out simple mechanics behind them. So science is such a complex phenomenon that millions of people are involved in scientific discoveries with heterogeneous behaviors and outcomes. So how are they grouped? How are they evolving? And how are scientists and papers linked? And how do scientists and papers get recognized? If we consider science as a dynamic process or a network, we might get a quantitative understanding of how scientific activities behave. So let's take a quick glance at the lab's recent studies on this topic. So in a 2013 paper, my colleagues analyzed the number of citations each scientific publication gains in every year after its publication. So as shown in the panel, that each curve represents a paper, and the curve looks messy. That they found 3 parameters to fully describe all those curves and capturing the dynamic process of paper citation and accurately predicting long-term impact. And in 2014,
so each of those lines
is one paper, yes. And this is the number of citations each paper gains.
How come everything at 1960 isn't blue and 1970 isn't red? I mean, you have the same axes labeled, and you have 2 heuristics labeled for both for year. So they must mean the current year and the published year, or?
The colors are published year, and and the horizontal axis is also published year. Not published year, the actual years.
The color is the year it was published.
The colors are published years, and the horizontal axis is the year after its publication.
How many citations it has? Got it.
Okay. So this is a 2014 paper that my colleagues developed an algorithm to allocate scientific credit to paper co-authors. So a trivial solution to allocating with author order, which does not always work because author order means differently in different disciplines, like in computer science and in math. The first author does not always mean the most contributing author. So we need to find out a discipline-independent algorithm to allocate credit to co-authors. So this algorithm leverages the citation network to analyze co-cited papers. A co-author is recognized more if he frequently appears in co-cited papers. So this algorithm accurately recovers Nobel Prize winners from multiple author winning papers. And in a 2015 paper, my colleagues found a way to automatically detect physics papers and analyze the evolving connection between physics papers. And this is a non-trivial task because not all physics papers are published on physics journals. Some are on general journals like Nature, Science, and a label spreading algorithm does this work and detect the boundary of physics. And they find that some subfields of physics are becoming more insular now with less citation links across subfields. And the most recent work is about gender. So in many aspects of scientific activities, female scientists are underrepresented. For example, in the history of Nobel Prize, a total of 851 individuals have won Nobel Prize in natural sciences, including physics, chemistry, and medicine. And only 48 of them are women, occupying a very small portion of the population. And as reported by US NIH, the average size of women's awards has consistently been much lower than those of men. And female scientists in the US earn much less than male scientists in biology, chemistry, and physics. So those show the gender disparity in the academia that in many aspects of scientific activities, female scientists are underrepresented. So we are trying to quantify the phenomena and find out the reason behind it, what makes the gender disparity. And our solution is based on a big data analysis. We analyze one of the biggest bibliometrics dataset authorized by Web of Science. It contains the meta-information of all journal papers from 1900 to 2016. And there are a total of 55 million papers authored by 7 million individuals. And we collect their first name and compare with name library from more than 100 countries to infer author gender. And we end up with gender labels of 3 million authors with confidence. So therefore, we are able to analyze those authors with gender and with their published records, their citations, their affiliations, and disciplines. So we start to establish, sorry?
So they provide 55 million papers full text or just metadata?
Just metadata. We don't have PDF.
Is there a way to get
That data is not available, is it?
That's
of
a
that
commercial data. The sale purchase. Sale access. Sorry.
This is the Russian website, you can get it all from.
Wondering how you identify gender? Is it some kind of an automatic procedure, or how do you do it?
We compare first name with libraries.
First name with
Library. So so we have we use a commercial engine that they have the data, which name means man, which name means women in most countries. Like Michael is man and Mary is women. So we do this for about 3 million. We do this for all the 7 million people, and we have identified about 3 million of them. And we lost a lot of them. Some of them are not identifiable, like in China, in Korea, that people name does not tell their gender.
Does that data change over time? Because I can imagine some names like Leslie might have been more of a man's name, say, historically, which they might be more of a woman's name.
It is,
Or
but it occupies a very small portion in our data, about, I think it's below 1%.
Last question about the sample. So I also work with Web of Science, and compared to other databases, they don't catalog obviously all articles published. So do you have a good insight or an idea about what journals are not indexed by Web of Science? And because they also drop journals for certain periods over certain times, and they don't make that very clear. So I guess when you're making causal claims, do you have a good idea about what is missing from your overall data set that you start out with?
Yeah, so coverage is a problem about Web of Science that we know that they have better coverage on natural sciences, physics, math, computer science, but they don't have a good coverage on social sciences, politics, sociology. So we solve this problem in 2 ways. One, we try to identify as much papers as we can, and we try to infer their discipline labels besides the category provided by Web of Science. And secondly, we use another dataset to do cross-validation. We use Microsoft Academic Graph, and we find almost similar phenomena between Web of Science and Microsoft. So we believe our conclusions are consistent. Sorry.
I suppose you're going to go into affiliation to get the locations of these people, just looking at the abstract of the talk you've sent out to us. What happens if somebody from Harvard visits like London and he or she lists herself as a professor at like LSE or like Cambridge? Do they get categorized as like a London person? And then do you assign gender based on that location? Or do you have a way to follow the affiliation history of the person to track down?
Yes, this is an issue that we label gender with their country, that we use different data set for American people and Italian people. And so, which country we identify with the affiliation. And we use 2 ways to identify their affiliation, their most frequent affiliation or their first occurrence. And with the assumption that most people publish their first paper in their home country. And we found there's no difference between those 2. So we think the gender labeling itself is robust. Thank you. Any question about the labeling? Okay, so let's move on. Then we start to establish this phenomenon of gender disparity by checking the population trend. Then we report the number of actively publishing authors in every year since 1900. That is how many male and how many female authors publish at least one paper in that year. So no surprisingly, both number grow rapidly in the past century, and especially after the World War II. And in each year, there are much more male scientists publishing than female scientists. Though the ratio of female scientists increased from 14% to 35% in the past 60 years, female scientists are still significantly underrepresented. And we inspect the ratio of male and female scientists in each discipline and each country. And in all of 8 major disciplines that Web of Science covers, math, physics, computer science, politics, and psychology. And in most countries, we find more male scientists than female scientists. And besides, we observe that the gender disparity is not uniform. In some disciplines and countries like physics, South Africa, and United States, we see significant more male scientists than female scientists. And in some disciplines, countries like Russia and Argentina, we see a smaller gender gap between male and female. So what makes the difference? This will be our key to explain the gender gap later. So now we see men outnumber women. So it might not be fair to compare men and women as a whole, as a population. So therefore, next we focus on each individual to compare scientific performance of every single man and woman who will have better performance individually. So when we are talking about scientific performance, we usually talk about evaluation. There are many measurements to evaluate a scientist's performance, like H-index, impact factor. So here we use 2 of the simplest measurements, the total number of papers and total number of citations in a career. And roughly speaking, a scientist with a greater number of publications and citations are usually more recognized by the scientific community. So here's an example randomly select from our data. The green dots represent all papers of a single author, and we call the number of papers as the author's total productivity. And we collect the number of citations of each paper, and we sum up to the author's total impact. And we count the years spent between the author's first and last publication as the career length. And here a total of 11 years from 1994 to 2005. And we count the average annual productivity, which is the average number of papers per year. So those are the quantities we are mostly interested in an individual. And we calculate for every individual and see the difference between men and women. So here are the results. The men have significant advantages in total productivity. On average, a male scientist publishes more papers in career than a female scientist, as shown in the top bar. Here, those bars. The top bars in the left panel. Now, on average, the male scientist has a total of 12 papers in whole career, and while a female scientist has a total of 9 papers. And so overall, a male scientist has on average 26% more papers than a female scientist. So this advantage is consistent when we break down people into disciplines, into countries, and decades. So in almost all countries, all disciplines, all decades may have more papers in career than female. And the case of impact is similar, that we count the total number of citations a scientist receives in the whole career. And on average, men receive about 33% more citations than women. And similarly, the gender gap in total impact is observed in most countries, disciplines, and decades. So it is interesting when we break down people into 3 groups, as we show here and here. The top publication and cited author, middle authors, sorry?
Okay, so one question on graph D. Does that imply that that gap is increasing over time, or?
Yes, it's increasing. Sadly, it's increasing.
And same for H. For graph H.
Yes. So when we break down people into 3 groups, top publication and cited authors, mid authors, and lowest authors, we realize that the top men and women differ a lot, while the other 2 groups are almost the same. So this suggests that the gender gap in performance mostly comes from the top scientists. And we'll discuss this later. So now we know that there are much more men than women in academia, and men outperform men in most countries, disciplines, and decades. So we want to know why there's such a gender gap in the performance. So to explain the performance gap, there's a widely spread stereotype that men and women have different talents in science. Specifically, a lot of people believe women are less talented in STEM, science, technology, engineering, and math. And we examine the stereotype with annual productivity, which is the average number of papers each author published per year. And if we see on average a male physicist publishes much more papers every year than a female physicist, we might say the stereotype is possibly true that men have more talent than women in physics. But this is not true. In our data, on average, a male scientist publishes 1.3 papers per year, and a female scientist publishes 1.3 papers per year, almost identical. So the gender gap is very small, it's negligible. And when we break down the data into high-performing and low-performing people, into different countries, different disciplines, different decades, we still observe the same phenomenon that there's no consistently significant signal supporting the stereotype that men publish more papers per year than women. So now that men and women are publishing almost identical number of papers per year, what brings the difference in total productivity? And the answer is obvious that men stay longer than women. On average, a male scientist keeps publishing for 11 years, while a female scientist stays in academia for only 9 years on average. So the gender gap in career length is observed across countries, disciplines, and decades. So this is ironic that when people stereotype men are more talented in some disciplines, the actual fact is that men have no advantage in annual productivity, but instead in career length. So then we propose a hypothesis. Can we say there's a simple causation that men's advantage in career length leads to,
Does the career length include the PhD, or is it just post-PhD?
just from their first publication to the last publication.
So it could be with
Could be including PhD. Yeah.
Does it take into account biological age, or is it just academic length? So biological age, does it take into account that? So when they start their PhD and when they start their...
Not that, just publishing reports.
Have you looked at something like how many citations you get on that first publication or the first couple publications, or like how many citations on your most cited thing? And are there gender differences in that?
We
So
didn't.
there's other ways of cutting it than just like sort of number of publications per year.
We just count the number of publications per year.
Sorry, clarifying question. So the career length here is from first publication to last publication.
Yes.
But are the total citation counts that you're doing, do they include the post
Yes.
career? So
Yes.
it's just the citation counts are just forever.
Yes.
They go until today.
Yes.
Okay.
Yes. Practically, we count for 10 years. Sorry, let me answer the question first. So practically, we count the citation of each paper for 10 years after its publication. So it's fair to compare recent papers and Asian papers. So Asian papers won't have extra advantage because they have more time to accumulate citations. And we also normalize the number of citations of each paper against the citation inflation. If you have an idea that nowadays people get more citations than 100 years ago. So most of us, we publish papers might get more citations than Einstein because we have more papers now. So we have more citations now. So we also do normalize that. We can fairly compare nowadays papers and Asian papers.
What about people who are still active?
Sorry?
What about people who are still active, so they're not finished? So
Good question. We
there
don't
are
count.
younger women who are probably right still.
We don't count them. So for active authors, we remove them because it's unfair to estimate their career
How
performance.
do you know? How do you know exactly whether
For everyone that published paper after 2010, we remove them. We thought they are active. So all people we are analyzing here.
And you end up removing a lot of female
That could be.
scientists.
That could be because we
The increase in number of female scholars.
yeah, it could be. So in recent years, we see more female scientists.
Right.
So it is an issue that our analysis reflects the case before 2010, because we cannot compare active authors with finished authors.
Well, I just
Sorry.
thought this, back to what Kosuke said, but this may be just simply reflecting that the percentage of women actually is increasing, right? Even with that increase, can we expect that this would not happen? As long as the percentage of women is increasing
Yes,
from 1900s to up to now,
yes.
I think this sounds obvious.
This sounds weird. We believe this sounds weird. So, yes, previously we showed that the percentage of women in population is increasing, but the gender gap is also increasing. So for nowadays, we see men have much more advantage over women than 50 years ago.
But it's just, I think the issue is that for 2010, for the 2000s, you're looking at the 2000s. If you cut off all people that have published post 2010, then what you're comparing within the 2000s are possibly you're limiting a bunch of women and comparing it to men that are basically at the end of their careers, and so they have a lot higher. And I think that's right. That's because, and as you get closer to that cutoff point, you're exacerbating that gap. Because just I think that's maybe what they were getting at. So you would expect this to increase just based on the selection, not based on any kind of underlying trends about quality or productivity or anything like that.
We see the increasing is eventually not a jump around before 2010.
But I mean, but given the increase in given the relative increase in proportion of women and the cutoff rule, I think that's what you'd expect. You'd expect it to kind of like you'd be slowly phasing out younger women, or it's very difficult. It's so difficult to kind of explain this, but you'd be slowly phasing out, changing as you move from the 80s to the 2000s, you'd be slowly changing the composition of the two genders, and it would slowly start to look like, I think, women are doing worse because you're eliminating women that are still productive, that are also making up a greater share of the population.
Yes. Yeah. So we remove younger women that start recently, and it is possible that they contribute a great share to the science, but as we talk in this figure, that the gender gap in performance must come from the top scientists, not young scientists, not junior scientists.
But I think it's I don't want to harp on this for too long, but I think
Sorry.
I think it's just consistent with this idea, because what I think as you're getting closer to the 2000s, what you're doing is you're privileging the top these like kind of older male scientists that are not being eliminated by the cutoff rule, and so you would expect that to drive the difference between men and women. I think, if I'm thinking about this
Perhaps
correctly.
relatedly, why is the average career 11 years for men and 9 for women? How come it's not 40 years?
Most people quit after PhD.
They quit after what?
Most people quit after PhD. So people go to industry.
Oh, I see.
So is that the same as saying?
No one here about it.
So like a simple summary of that finding then is just that like more women go into private sector rather than going into academia. Like I think it'd be useful to see like the distributions of career length rather than just seeing the means, so that we could know like what percentage of that is like shorter tenure track careers and how much of that is just like dropping out after your PhD immediately.
Yeah, we have we'll talk about that later, but since you're asking, this is
basically a study of the people that just get a
This is
PhD.
the distribution of survival years that when people are dropping out. So this is the cumulative survival rate. I hope this answers your question. That about 20% men stays to 20 years, and about I think it's 10 or 15% women stays to 10 years.
So it looks like this gap starts at like roughly year 5 or 6 and stays roughly the same up until the death rates start to become the prominent factor.
Yes. So at the first they have almost the same dropout rate, and then women have a consistently about 2% higher risk to drop out from academia, and that makes the consistently lower cumulative survival rate. Okay. Yes.
Could that be explained by less women perhaps getting tenured? Because right after the 6-year mark, that's when it starts to drop off.
But this is from first publication, so presumably that would be like, so that would be like the length of a PhD or very soon out, or the length of a PhD plus a postdoc.
Yeah. Sorry.
Or first kid, right? Like,
Yeah.
Could be. Yeah. It is possible.
Average if you're cutting off. You know, like if there isn't more modern norms around childhood leave, right, and you're cutting off the 2 planets, right?
Could, yeah, it is possible that when we are doing this and when we are giving talks, we are asked a couple of times that it is possible that women quit because of feminist or family pressure. We don't know because we don't have the data, but we think it is possible.
So how do you track a single person across the career? Females can change names after marriage.
It is a problem. It is a problem. That so we do the name disaggregation with Web of Science data. That they provide us the individual records, and so as far as
they did the matching.
Sorry.
So you mean they did the matching, or you did the matching?
They did the matching, so we didn't do that.
Yeah.
And we inspect this with manually crawl the CV online to check their accuracy, and the accuracy looks fine. But we did not check the specific issue that women change their last name after marriage, because we don't have answer to validate that. But this is the issue. Okay, sorry.
What happens to the women who change the last name? Do you reset the career or?
So yeah, this is after Xiang's question that if women change their last name, they will be probably considered as a separate people.
So a bunch of people who are recruited as academic age 1 could be actually just married right before.
Could be, yes.
So there could be a marriage effect, the spike and then the decline.
Could be, yes, could be. Okay. Yes.
Cultural question: how common is it for women to officially change their names in America and other countries?
We don't have the data to support this.
The US is very high.
Is there any study?
Can I make a comment as a married academic woman? I don't want to speak for all academic women, but we're generally told not to change our names after publication in order to keep it consistent. So every married woman I know who has changed her name is stuck with one name. But this is a sample of like 20 or 30. But given that we have no data set at all, I would suggest that this.
Thank you. Thank you. Yeah, this is the issue that we need to investigate. That we hope this won't affect a lot of people.
Will affect a lot of women.
A lot of women, yes.
Which might be a problem.
Okay. So, where were we? Okay. So here the career lengths. Yeah. So here we talk about the career lengths that the men have a much longer career lengths than women. That might explain the phenomenon that men have more publications and citations. So we here propose a hypothesis that is it possible we see the gender gap in career lengths solely explain the gender gap in performance? And let's start with 2 examples, Netherlands and Cuba. In Netherlands, men and women differ a lot in career lengths and they differ a lot in total publications. And in Cuba, there's small gender gap in careerness and there's small gender gap in total productivity. Can we say this is a coincidence? This is
How
not
much more
coincidence.
in Cuba than the Netherlands?
Different y-axis.
Oh, no, y-axis is different, right?
Plus there's some field heterogeneity there.
So this is consistent to almost all disciplines and countries. We observe a good alignment that in some countries and disciplines like biology and Germany may have greater advantage over women, and in careerness and in total productivity. And in other disciplines, countries like applied physics and Cuba, they may have smaller advantages in both careerness and total productivity. So the simple linear relation shows that gender gap in careerness might solely explain the gender gap in performance. And we try to validate the hypothesis with matched samples. We manipulate to remove the gender gap in careerness. So if the hypothesis is true, there should be no gender gap in performance. So by doing so, we select about 70,000 women and 70,000 men, such that every female scientist is matched with a male scientist with the same careerness, discipline, and country. So therefore, in these samples, in each discipline, in each country, men and women have identical distribution of careerness. So we want to see what will happen to the gender gap in performance in these samples. So the result is mostly, so this is the gender gap in performance in the population, that men publish more papers and gain more citations. And this is the gender gap in performance when we control the careerness. The gender gaps are largely reduced from 26% to 10%, from 33% to 11%. So we are quite satisfied with the result that when we control only one factor, the careerness, it explains a major part of the gender gap in performance. And this confirms the importance of careerness, that it also shows that the stereotype that women are less productive is not supported as a major cause of the gender gap in performance. So when men are having equally long careers, they are producing and being recognized almost equally. So the next question is why women are having, sorry.
I mean, as before, you're doing various variants of selecting on the dependent variable, selecting on things that are affected by the dependent variable. And it's well known that for fancy language, Perl, you're doing collider selection, that creates all kinds of biases in your estimates. So like how productive I am probably has a whole lot to do with, when I decide to keep publishing or I stop, right? Gary's gonna go to 105. So, there are huge mathological problems, both with this and, what was being talked about before. And, if you thought about it more in terms of a formal causal model, you would see that, kind of how it is that you're selecting your data is the potential to be producing the results that you're seeing.
Yes.
Go on.
Sorry. Sorry, go ahead. Sorry.
So like, for example, what about the possibility that maybe more potential productive, intellectually productive women can quit early just because they have to take care of, kids or something like that. Whereas the male, the dropout reason for the male scientists might be entirely different.
It could be, and in later sections we'll talk about high-performing women are more probable to drop out than high-performing men, and the gender gap is even larger than low-performing women and men.
So matching, but matching on the career ranks might be problematic as the career goes on, because then the people who are left out, decided to stay in academia might be very, very different between men and women.
Yes, it could be. So this match sample is a very rough experiment, and we try to make it final in the next step. And we'll inspect.
This might be a feature rather than a bug.
Right.
I mean, it depends what the quantity. What are we trying to explain?
Yeah. So the question is why women are having a shorter career. The answer is dropout rate. In the left panel, we report the dropout rate in each year after scientists publish their first paper. And we see a consistent trend that female scientists quit at a higher rate, about 2% higher than men, in every age, in every stage. And so this results in a consistently lower survival rate, as shown in the right panel. The women are less probable to survive than men in the academia for 10 years, 20 years, or 40 years. And we want to know why women quit at a higher rate. So a simple hypothesis connects the dropout rate with performance, like the published papers. It's straightforward to assume that if you are publishing more paper, you will be less probable to leave the academia. And this hypothesis is empirically supported in our data. We report the expected chance that the scientist will drop out in the next year, given the cumulative publications within first 5 years. And it shows a clear trend that the productive authors are less likely to drop out. But this hypothesis, if it is true, does not explain why women quit at a higher rate, because previously we showed that women are equally productive than men. So with identical number of papers per year, women and men should have identical distribution of number of papers in the first 5 years, and they should have the same dropout rate. But it is not. So when we repeat the experiment for men and women separately, we find another factor that contributes to the dropout rate, that's gender. That given the same number of papers in the first 5 years, women are consistently more probable to quit the academia than men.
I'm not sure if you really ruled out that possibility, because what you showed is that after both men and women have made the decision to stick around in academia, they're equally productive. Right? You didn't show that expected publications before the decision to stay in academia, apply for an assistant professorship or whatnot, is equal. I think that saying that could potentially still be, for whatever reason, what's driving the dropout rate. You can't rule out that possibility.
We don't know. We don't know whether they choose to leave or they are selected out. We don't know that. So what we can observe from the data is they stop publishing at a higher rate.
Right, but you just made the point that differences in the expected number of publications can drive the differential in the dropout rate. And
Yes, that's what we also from the data, that people with different performance have significantly different dropout rate.
But are you not? Are you looking? You're looking at, or I guess it's not clear who you're comparing. It's not clear who you're comparing with whom, right? Because you're comparing people who drop out after 5 or 6 years, maybe when they have very little number, small number of publications.
Mm-hmm.
Can you make that? Can you clarify that?
So sorry, are you arguing if this is true for every age, for the early stage or late stage, from PhD for full professor?
I guess I don't quite understand how you make the claim that you can rule out differentials in expected publications as a potential driver of the differential dropout rates.
Sorry, say again.
I'm not sure.
Okay. How exclude the possibility?
How you can rule out the possibility that men and women see different prospects when they make the decision to stay in academia, and for that reason have differential dropout rates.
So I think he's using the number of publications up to that point to be the potential, right? Is that the idea? So if you and I publish like 5 articles up to now,
yes,
then you decide whether to drop out or not.
Yeah. So the assumption, yeah,
right.
Partly, yeah. So assumption here is that when we see they have the same number of papers in the first 5 years, they might have the same expectation in the future. But honestly, you want to say that there could be different expectation, even they have the same performance.
Yeah, I mean, related to that, would it be possible to see if there's a slowdown prior to leaving out in publication? Because if you can see there's a slowdown, maybe that's some evidence that they're struggling in academia. If there's no slowdown, there might be more attractive options outside of academia. So there's no really.
So if they are increasing or decreasing,
yeah, it's just really looking at the rate of publication prior to dropout. Maybe that could be a more conclusive evidence, helping sorting out what is the driver. Is it publication or struggling in academia or other attractive options outside of academia?
Yeah, this could be.
But that's
Could be a
problematic
factor
because
with
you
it.
don't count what type of publication you have. So if you publish in a top journal, you might publish at a lower rate than if you just push shit
Yeah.
out.
Sure, but that would be, I mean, it should be possible to address that by just sort of slicing the rate of publication per top journal or overall, maybe?
But then you would need the data on what is the top journal at what point.
Yeah.
So it's also the expectation to the future, right? So if they have different expectations to the future, they might have different decisions.
Yeah.
It could be, yeah. So there could be a lot of factors that can affect a person's decision whether to keep in the academia. And here we choose the simplest one, that how many papers you have already published, because this is the one we can observe, and we can for sure we know these numbers. And in August, we found this number has a good correlation with the dropout rate. So for this stage we use this to explain the story between men and women, and it could be possible that we involve more factors to make this more complex models and more accurate in prediction, in explanation. So for now we try to make this simple, so we use
I like
the simplest version. But thank you for the suggestion.
We'll definitely be more sort of behavioral indicators, like if there's a slowdown, sort of there's a larger reason.
If they are going increasing or declining, if they are going to from conference to journal, or from journal to conference, that could be make a difference. Okay. So so this is the example at the age of 5. So this is after 5 years after the first publication, and this is consistent for every year. Yeah, we check from the second year to year 26, and we find in every year this is almost the same. With the same number of cumulative publications, women have consistently a higher risk, about 2% risk, to leave the academia than men. So this is not good. This is sad news. But we found out even more sad news, that this inequality is not equal. It is against high-performing women. So when we compare the dropout rates of high-performing and low-performing men, and realize the gender gap in dropout rate is more against the high-performing female scientists. For example, among the lowest 10% productive authors with a total of 3 papers in their first 5 years, women are 15% more probable to quit than men. And if they are proficient and have 27 papers, which are the top 10 productive, women are 150% more probable to quit than men. So this gives an additional layer of gender gap that selects out more high-performing women. And we confirm the additional gender gap is consistent. So in the green column, we report the difference between dropout rates of high-performing men and high-performing women at every age, every academic age. And in the purple column, we report the difference between dropout rates of low-performing men and low-performing women. So at every academic age, the green column is much larger than the purple column. And this is independent from how we define high-performing and low-performing. No matter it's top 10, it's top 5, top 10%, or top 25%. So the conclusion is consistent. That no matter how we choose high-performing and low-performing men, we still observe that the gender gap between high-performing men and women is much larger than the gender gap between low-performing men and women. So what's the consequence? When we say extra high-performing women are selected out from the academia, the population structure is changed. So for men at the beginning, we have much more low-performing men than high-performing men. And 50 years later, there are, where's my point? Okay. So at the beginning, at year 5, we see there are more high-performing men, there are more low-performing men than high-performing men. And after 25 years, there are more high-performing men than low-performing men because of the publish or perish the hypothesis that more that low-performing men are dropping out at a higher rate than high-performing men. So the population structure has been changing in the 25 years, but the reverse for women is prevented. 25 years later, the population of high-performing women is still below the population of low-performing women, because extra high-performing women are dropping out in the. Yes.
I have a question. So there is some evidence that men are more overconfident than women. Some evidence. Is it possible that this is driven by the fact that men, being overconfident, think that they can also enter into new fields, and as the authors get older, the fields mature, so the needs for the studies decline, and female, being less confident than men, enter into like new fields less frequently than men do, hence they drop out of your sample.
Yeah, I think this it is possible. Like that gentleman's question, that there could be a lot of factors to determine people decision whether they could keep in the academia. Confidence could be one factor. The men are more confident, so men are more probable to stay there. But confidence is not the only. Confidence is not the only factor that determines. That I would most believe that performance could make a more important role, because if you want to stay in academia, you need fund, you need position, you need a tenure track, and your performance talks, not your confidence, not only your confidence. So that's why we try to control the performance as the cumulative number of papers. That when people are evaluating whether they give fund to you or they give admit you to the tenure track or tenure, they mostly evaluate with your performance. So that's why we choose performance as a deterministic factor. But I think it could be possible that confidence and other factors could make a difference in it here.
Wouldn't you be able to test this directly? I don't know if Web of Science has this feature, but at least PubMed, they have a keywords features where you can look at the keywords of each article and see whether they start using like new keywords, authors are using different keywords.
We did. We are not reporting here, but we did. We did this in APS. It's published by the American Physics Sociology. Then we have the publication since all the physics papers since 1900, and we know they have a PAX code to classify, to categorize each paper into a topic, and we calculate the diversity of men and women, and we find no difference between them. So men and women are almost equally diverse into new fields or stay in their own fields. But thank you for the question. So sorry.
So you're framing this as extra high performing women quit at a higher rate, but would another way to think about this be that the factors that may drive women to quit academia, say children, for instance, right, in absence of childcare, just affect all women equally, whereas for men the selection mechanism is more selective, for like, so for men it's clear, like you either publish or perish, as you pointed out, whereas the additional factors that may drive out women do not differentiate between different women, affect all women equally, and therefore lead the ratio to adjust at a lower rate. Do you know what I'm trying to say?
Yeah, and yes.
So it's not maybe it's not that extra high performing women quit at a higher rate. It's just that they're affected by all the same things that low performing women are affected by as well. Right?
I know what you're talking about. So family pressure could be a factor that drives women out from the academia. But here we're trying to say that high performing and low performing women, they are suffering different extent of gender gap, and so that could not be explained by family support, because there's no reason that high performing women are more probable to have more kids. Sorry. Oh, sorry.
It just seems like, so I think one issue that I keep having with this is that we don't, to say that the dropout here is like indicating a lack of success and especially since we're seeing that high-performing women are the ones that are dropping out, it seems strange to me when it could be a number of different factors, like they're actually taking jobs in industry that are better for them than academia, or they become like higher level administrators at universities and stop publishing for that reason, which also could be considered a better job. It seems like in order to get a sense for whether or not this is the normative, you seem to have a normative implication that this is a bad thing, and it may be, but I think you'd actually have to know what dropout meant for the people that are dropping out. Is it the case? So just randomly sampling, like a set of men and women that dropped out, just to see like what was their career path afterward, I think would be really helpful to get a sense of this, because otherwise it's very difficult to evaluate whether or not there should be any policy intervention to prevent this. Right, because maybe this is just people picking jobs that are better for that.
Yeah, it is very possible that we consider this. So the dropout rate, the dropout of high performing women, it might not be a bad thing for themselves, because they might go to industry for higher salary or they go to administrate in university as a higher position. So it might not be good news for them, but it could be a loss to the scientific community that we lost high-performing scientific staff population. So this is what we're trying to talk about today, that we try to evaluate the scientific performance of men and women, not their personal careers. So it could be good for them to leave for industry, and but we don't have data to quantify that. What we can do is we try to analyze how those factors affect the scientific outcome of male and female authors. Thank you. Okay, so ladies first.
Thank you. I wondered if you had tried to run this analysis again using a different measure of low performance and high performance, namely including the number of citations.
Really?
You did?
Yes.
Do you have another slide for that also?
No.
Or did you find something? Did you find anything different, perhaps, than what you have here?
So it's a bit surprising that in our analysis we found the number of citations does not play an important role to dropout. So it's almost the same for high cited people and low cited people to drop out, but it makes a lot of difference for high productive people and low productive people.
So I'm wondering, because I suppose thinking about the same question as you, and I also think about whether if you can compare the positions such as the assistant professor, associate professor of the woman, if this position will influence the dropout rate of the women and the men.
It could be, yeah, and I know there are literature saying women are less probable to get promoted,
yeah.
to get into tenure track or full professor.
Because I read some books that says if a woman wants to be sound, they are the same excellence as a man. They need to provide more performance. That means if a man and a woman works the same level, then the man is easily to be promoted. And
Yeah.
then that's maybe the reason we'll let the women have high dropout rate.
Yeah, I think that's true. Though we don't have, so I think this is true that, and agrees with what we found here, that when men and women, they have equal performance, men are more probable to stay. I mean, to stay maybe to be promoted. We don't have the position data. In our data, we say that women are more probable to drop out, perhaps because they fail to be promoted and they fail to get fund, and they have to leave.
It looks like a very sad environment for
It
women.
is sad, yes.
There's a lot of conjecture about why women are dropping out. Have you considered asking?
Sorry?
Have you considered asking?
Ask them?
Yes, ask.
Yeah, we ask a couple of them, but we cannot ask many of them.
I mean, ask in a systematic way. But it's a wonderful data set that enumerates all female scientists and all male scientists. You know the data dropped out. It seems like a straightforward validation exercise. There are lots of theories that are being generated from this data. Perhaps, we can take a page from labor econ, where the gender gap has been studied for a long time with structural models and survey evidence, and perhaps gain a little more outside knowledge from this data set, so we're not all conjecture.
Yeah, good suggestion. Yes. I think if we have time, we need to ask them for systematic survey why they choose to leave academia. And thank you.
Understanding this pattern by field. I'm asking because dropout could mean from publishing activities could mean differently by field, and that the prevalence of or continuance of publication in some other countries other than US happens early in career, and the fields that experience that tend to have more women than other fields. So, for example, if you compare engineering, overall engineering, and sociology in a I'll just take the example of a country that I'm from. So let's take the example of South Korea. So the engineers with lab system, once you become senior, it's far easier to just keep publishing with a bunch of co-authors that are normally just your RAs, lab members. In sociology, it's a lot harder to do the same when you become a senior. And you have a lot of opportunities to become an administrator. So it's basically seconding the point that you made. And stopping to publish because you're already tenured and you don't need to really show your or prove your productivity. So if you look at the patterns and compare it by field, I think it will reveal some patterns of whether it's because of the other differences by field or requirements, or it's just gender.
We did.
Oh, you did? Okay.
Yeah, we did. We repeat every experiment we did in every discipline, and the conclusions are almost the same.
So
more or less almost the same.
Okay, even in the fields and countries where continued productivity is not required, the same pattern is shown. Like the dropout is happening at a disproportionately high, like that rate for women against men.
We did for disciplines, but we don't do this for countries because website has poor coverage over countries.
Okay.
So for most countries, we don't have enough data before 2000 to make a statistically reliable result. But we do have full coverage for every discipline, and we repeat everything in every discipline, and they almost look the same. Thank you. Over there. Okay. Oh, sorry.
A few questions ago, you said there was no dropout rate difference by citations. Did you mean total citations or just citations
Cumulative
per
citation.
paper?
Yeah. We mean total citations.
So not even controlling for number of publications?
So so this an interesting thing that men and women, they have almost the same citation rate. So they have almost equal number of citations per paper. So we just control the total number of citations.
But there's no dropout rate difference based on the total number of citations.
There's no lot difference, not as significant as this one.
Okay. Because I mean that suggests something different about this, right? It suggests that people are staying in with lots of publications with low citations.
So the story about citation is that when people have very low citations, they are high probability of dropout, and the curve goes to flat very soon. So as long as you have about 50 or 100 citations, it does not make any difference afterwards. So here's the last section of this talk. So we report that men and women, they have different dropout rate given equal performance, and the gender gap is even against the high performing women. So that explains the phenomenon reported in the right panel, that the gender gap in performance does not occur from the beginning, but emerges with time. So for short career people, there's almost zero gender gap in performance. Men and women are almost equal. And for long career people, like when people are staying for 50 years, 20 years, 25 years, there are gender gap. The men have more papers than women. So we say this explains that the gender gap in performance, it is not from individual. It is not from a single man performs better than a single woman. It is because of the composition difference that extra high performing women are selected out. So when we compare the average performance of all men and all women, we see the gender gap emerges. And one last, okay. And we try to estimate the contribution to the gender gap in performance. So we try to validate whether the gender gap in dropout rate explains the gender gap in performance. So we manipulate people by analyze their number of publications at every age and assign them a simulated dropout rate. So we can simulate people to drop out at any age. And by doing this, we control men and women to have identical dropout rate, given they have the same age and the same performance. So this is a result when we remove the gender gap in the productivity-based dropout rate. Men and women have very close performance. The difference in total publication is just 1.6%, almost negligible compared to, sorry.
How can you tell their age?
Sorry?
How can you tell their age?
Not natural age, the academic age. I mean, how many years after your first publication?
Yeah, but that brings us to the second question is it possible that women tend to publish earlier, like publish the very first article earlier than men scientists? In that case, you are like comparing a lady at 18 years old published the first article against a man published in 22, and so you are kind of like overestimating women at their initial stages.
Okay.
So like if you go back to two earlier slides, just go back 2 slides.
This one?
Yeah, like on the right hand, right? If it is the case that women publish, like, for example, 2 years earlier than men, and if you want to control their biological age, and you just arbitrarily switch the red line leftwards a little bit, then the two lines will converge. If hypothetically their biological age can show that way. Right? I don't know if it's the case that, because women scientists, they probably join labs earlier than men, like students. Is it possible, like undergrad, women tend to be more, are more likely to overachieve in their undergrads. Right? We have the data that more women major in STEM majors in college. They go to labs earlier than men students, published before they graduate from undergrad.
Okay, thank you for the suggestion. So the reason we don't choose biological age, but instead we use academic age, because we believe that scientific discovery, scientific activity needs training. So it's more important when you enter this lab, when you start publishing, and it's less important you enter a lab at the age of 20 or at the age of 40. So we believe the training years makes more different. So that's why we choose academic age to distinguish junior and senior people. But thank you for the suggestion. Thank you. Okay, so this is the last part that the right bars here. This is the case that we manipulate dropout rate, that when men and women they have equal performance at equal age, at the same age they should have equal dropout rate, and the result is the men and women they end up with almost equal number of publications. So this is the final result. So this is the take-home summary words that what we did in this project, that which established the worldwide gender gap in population, and men outnumber women, men outperform women in almost all disciplines, countries, and decades. And the gender gap in performance could be explained by the gender gap in dropout rate in two folds. That we have an age-dependent gender gap. Then women have a consistent higher dropout rate, higher risk of dropout than men, which shorten women's career lengths. And we have a productive dependent gender gap that selects out high-performing women. So we are losing extra high-performing women every year, and that changes the population structure. And that's all for this talk today. Thank you.
Yeah, I think so. Just coming back to this point to hit it home a little bit, because I think it actually is pretty important to a lot of the points that you're making, is this idea of this cutoff at 2010. Just the sample selection that's going on could be really affecting the kinds of people that you end up with and the kinds of the relative dropout rates over time. Right? Because if I think about, I'm going to eliminate these people that potentially, they're going back farther and farther at their starting point. That I might be dropping people that are actually very productive, right? And so therefore artificially inflating what the dropout rate looks like, because I'm eliminating people that stay in and stay in for a very long time. And if those things differ by gender, then you can get a very different impression of what the dropout rate is for men and for women, just because of how you're selecting the sample.
So tell them how you would do it.
I mean, I think you have to do some sort of accounting for the censoring that's going on on the right hand side here. You basically have a survival model, and I would, instead of just cutting off the end of the distribution, you'd want to actually account for that survival either by trying to estimate what types of people are being censored by this, and then adjusting for that using some sort of weighting technique, or using all the kind of typical survival models that are out there for this type of data.
Can you just replace the decade of end graphs with decade of start graphs as a starting point?
I think you still want to deal with the dropout issue, because because the dropout, you affect the entire distribution of the dropout graph by selecting by dropping everyone that's censored, right? The entire shape of the graph could change from 0 to the end. So I think that's the thing that worries me about this, is that if you're selecting different types of men and people at the end, that's going to have a big effect. So it just seems like there's a robust literature of survival models in the social sciences and in biomedical sciences, and it seems like that would be a perfect application for this type of study.
Yeah.
Right, like truncation due to death.
Okay.
Or I guess not quite. But.
So
why not just not
so for this
back to scientists?
Just to answer the question, we did use survival model. We did use survival model to estimate the dropout rate, and we did change the cutoff ratio from 2010 to 2005 or 2000, or even to 1980, and we found the results are almost the same. So we don't worry.
It seems like that's moving it back in time. Seems like making the problem worse.
What happens if you don't drop the
what happens if you include everyone?
What else? So if we include everyone, we include active authors.
Yes.
And we have a lot of people in recent years.
And what happens?
I think
it's a different kind of bias.
So we'll have
I'd like to know what the answer is under this type of bias.
Because if the results are different, then it tells you something is going on.
Yeah, everything. So we'll have more junior female authors.
Exactly. But what?
And the female authors they will have, and so when we talk about the average performance of female, they will be lower than what we observe now. Because we have more junior female authors than junior male authors.
So it exacerbates the differences between the sexes, right?
Is
that right?
So I think it will enlarge the gender gap.
But it might not exacerbate the differences in average productivity per year, right? And then you would just, and then the question, like, then the story becomes very different because everyone's, and if it changes this turnout, this dropout rate story, then it's like a very different conclusion.
The productivity per year is sliding. Sorry,
An action strategy to just compare people at the atomic unit here is the person year, or the person unit of time, right? And so when you're constructing a matching strategy, you're constructing off the whole regime. What you're really interested in is, at a given time point, this is a standard hazard type model. How does being female above and beyond all other observed traits predict your probability of dropout, of successful articles, etc. Right? And so you're just mashing things together a little. I mean, you could just fit this with a single structural model as they do in labor econ and kind of get all your answers. So I might just consider looking at, Claudia Golden's lit and just seeing what happens when you apply one of these very basic workforce models to what is essentially a well-behaved longitudinal problem.
Thank you.
Is that what you were saying?
So before I answer
Sure.
the question,
That's the, yeah.
So before I answer your question, I want to say that the annual productivity per year is almost consistent in the past 50 years. So it does not matter when we cut them. So
Yeah, that's what I'm saying. Yeah, I mean, I don't think obviously the total number, like the accumulated number of citations and productivity will change if you include the people in the last 10 years or whatever. But but it might be the case, and probably is the case based on the rest of your data, that annual measures will not change.
Yeah, and so to answer your question, that you mentioned the start year and end the year. Here we report the end of year. So we try to exclude the possibility that for recent years so if we report them for people start in 2000, we have very junior authors, and it's unfair to compare them with senior authors. So in everywhere we report about decades, we report the year people finish their careers. Okay, and I see hands over there.
It's just a general remark. Being a former physicist, this is not the first talk that I'm seeing by a former physicist and engineer team of physicists doing something related to social science with people from other established disciplines being mad that there are established techniques and methods like decades. Why aren't you even using them, and why aren't you aware of their existence? I think it's a problem of multidisciplinary research in general. I don't know how to, because it's a theme. It would be very good that it would be resolved somehow. I think what would help is having an economist or sociologist or political scientist in the team, which I've seen many studies do, but some don't. And those who don't sometimes have to reinvent the wheel. There are some wheels that you fail to.
Yeah, thank you.
Yeah, sociologists, Chris is called, but they have this cohort time, this period.
Yes.
And then identifiability results. So if the bias changes over time, and that would mess up this analysis. You want to probably follow the cohort, but then so this.
It's actually a hard problem. So if you did this model that Peter was saying, which I totally agree is the first thing you should do, because it at least by assumption deals with a whole bunch of different things with an assumption that sort of could be right. But it's hard. It's a hard problem, right? Because there's more and more women. There are probably different types of people. Like you have graphs that go back to 1950. The women back then, they weren't getting any benefits, right? So the women who are finishing their careers now, but not at year 9, at year 30, are just utterly different people than the women that are starting now, right?
Yeah, could be totally
with all the benefits of not only affirmative action, but actual help to help them do the things that they would normally do, and less bias and all that stuff. And so you have period and cohort and age, all this stuff happening. It's it's going to be like this model is going to be pretty model dependent probably, right? But that's how you're going to have to draw your conclusions, right? You're going to have to defend a particular specification that specifies all the different pieces of the model. So
I agree with Gary and Costa.
Thank you.
Yeah, I think a simple suggestion is to not censor the data at the end. Just include everyone and run a standard discrete time logic model predicting the hazard dropping out every year using individual characteristics of the past.
Okay. Actually, we did.
Oh, really?
Yeah, we did the version with everyone, and I kind of forgot the result, but I think that should enlarge the gender gap in performance.
I think that would address Matt's concern about right censoring.
Thank you.